Remember, these are pretty important problems here. So let's make sure we practice these on our own from scratch. Just listen for a few minutes and then try to get this stuff on your own, especially once you get 4 or 5 of these. You'll start to get your confidence going up with those, okay? And then you can just rework those problems and just try to master those kinds of problems right there. So they give us the graph of f, and they give us g is the integral of f, right? So right when I see, doesn't matter what that number is, it's always going to be a constant down there. When I see a number, when I see the integral like that, g is the integral of f. So when I do the derivative of the integral, I get the inside function. So g is the integral of f. That means g prime is equal to f, which means g double prime is equal to f prime. So I'm going to be using that quite a bit on these couple of letters here. Now, g of 0, you're supposed to, like, just if I give you g of x equals 5x plus 2, you take the 0, you plug it in for x, right? So if I give you g of x equal this integral, you got to take that 0, plug it in for that x right there. So that's why I said g of 0 is from -3 to 0 of f of t, and then that's the area between -3 and 0. So that is, you can even draw all over that thing, all right? This is going to be a trapezoid. And I did, this is the base was 2, this is a base of 1, so I did base 1 plus base 2, that's 2 plus the 1 divided by 2, and then the height is equal to 3. So I did the area of the trapezoid between -3 and 0, gave me 9/2 for that. When it says g prime of 0, I know g prime is equivalent to f, so g prime of 0 is equal to f of 0. F of 0, this is your f graph, so that just means when your x equals 0, what's our y value? That's just equal to 1 right there. I'm gonna do B and D first because I think once you get the hang of these, you actually will like problems like B and D. Letter C kind of sucked a little bit there, but B and D, I think that you'll like those as we go forward here. Now, for part B, it says, where does G have a relative maximum? Think back when you made your X, Y, Y prime chart, what made it a maximum, right? Look at that Y prime row. If your Y prime switched from plus to minus, that means our original function went from increasing to decreasing, and then that would have been a relative max right there. So I jotted down pretty much the justification for myself in these problems, or I try to talk myself into getting the right answer. I put down first, G has a relative max where G prime changes from positive to negative. And then since G prime is equal to F, that's where F changes from positive to negative. And that's when we're looking at the F graph. Now, if you have that F graph, if I tell you a particular graph is positive, that means that particular graph has positive y values. It is above the x-axis. If I tell you a particular graph is negative, that means it has negative y values. It's below the x-axis. So you're trying to figure out whether this given graph changes from positive to negative. That's where this given graph changes from above to below the x-axis right there. So if you need to make a note for yourself somewhere in parentheses, hey, I'm looking for where it went from above to below, so you know when you go back and study this thing, you know what it is that you were thinking about, go ahead and do so. But you're looking for where this given graph goes from above to below the x-axis. That's at x equals 3. Now, we pretty much have all that justification there. I think if I just kind of circle all that, I think I'm going to be good there. I kind of like to just highlight that again. It doesn't take too long. I just put G has a relative max at x equals 3 since G prime is equal to F, changes from positive to negative. That's like a succinct way of kind of combining the G prime and F being equivalent to each other. Now, we didn't have to do this, but look at this x equals -4. X equals -4 is actually a relative min because that's where, because G prime is equal to F. So this is the F graph. This is also the G prime graph. And the G prime changes from below to above. So the G prime changes from negative to positive. So at -4, that would actually be a relative min on that G function right there. That's just a little bonus knowledge thrown at you real quick. All right, letter D, right? We'll come back to C in a second there. Letter D says, find the point where G has a point of inflection. So I jot down for myself, I talk myself in getting these right. I jot down G has an inflection point where G double prime changes sign. And then since G double prime is equal to F prime, that's the same thing as me saying where does F prime change sign. Now, if I was given the graph of F prime, I'll be looking at where that graph changes from above to below or below to above the x-axis, but I'm given the graph of F. So to get from F to F prime, that's the same thing as saying what's the slope of that given F graph. We know the derivative is slope. So the F prime changes sign. That's the same thing as me asking where's the slope of the F graph change sign. So if I want to know where the slope changes sign, that's where this graph changes direction. See how I have a positive slope and then a negative slope? So where that graph changes from going uphill to going downhill, the slopes of that graph change sign, which means the derivative of that graph change sign. So when you're looking for a slope changing sign, you're looking about where does this graph change direction. And then so where it changes direction, it goes up, then goes down, boom, at x equals -3. It goes down, continues to go down. And then be careful here, it goes down and then it goes back up right there at x equals 1. And then it goes up and then goes down at x equals 2. So those are the 3 points of inflection. And I just stressed that again like I did up here. I said G has inflection points at x equals -3, 1, and 2. Since that's where the G double prime equals F prime changes sign right there. So I used to get so bogged down when I first started teaching that stuff. My students probably hated it. I hated it. Just I used to make the charts and stuff like that, but all these AP conferences I've gone to, they don't, the charts are good to organize your information, but it still doesn't justify why it's a max and then why it's an inflection point. You got to stress these things here. And then once I started thinking of it like this, then I know exactly where to look at to get my actual answer. I don't have to bog it down with a bunch of extra charts there. So you'll keep seeing those properties over and over again. And so let's try to become experts at that. And if we got some questions, we got to make sure that we ask about those at some point. Okay, letter C. The key thing here is says absolute min, and it gives you a closed interval. So right away, those are more work involved than B and D. That's why I kind of did B and D first, and I came back to C. But when you see the absolute extrema and in a closed interval, you have to make an XY chart and you got to check the endpoints and the critical numbers right there. So I'm going to make an XY chart. You see, that's what I'm doing here. I'm making an XY chart and I'm checking those endpoints, the -5 and the 4, those are on there right away. Now let's talk about how to get the critical numbers. Normally to get the critical numbers, if you have an actual equation of a function, you take the derivative and you set that equal to 0. But what you're finding when you're doing that is like the relative max and the relative min. So notice that we already talked about this earlier. You're trying to find the absolute min. Those could appear at the endpoints. Those could appear at the critical numbers, like a relative min. So what our goal here is find a relative min, and then we'll check it, see if it's an absolute min. So as we look at that, we already mentioned how this was on the G function, this is a relative max. And we also mentioned how this was a relative min. So since this G graph has a relative min at x equals -4, since this is your G prime graph, the G prime is equivalent to F. So since this graph changes from below to above, that's a relative min on that G function right there. And then so that's a relative min, that's our critical number. And so I got to check that on my chart, see if it's like the actual absolute min. It might be, or the endpoints might be something lower than that. All right, so that's what I start with first. Those y's were blank. I just trying those x values here. And then what we got to do, you're trying to minimize the G function, and this is your G function right there. So you got to take those 3 x values, plug them in for x, similarly how we did with that very first problem right there. All right, now I have a bunch of work for this last one. You don't need that much work there, so just pay attention and listen here, and I'll explain that to you. But G of -5, you're going to take the -5, plug it in for that x right there. So you get the integral between -3 and -5. Now, when it's not least to greatest like that, you're supposed to flip them back. But whenever you flip the numbers attached to the integral, you got to stick a negative in front. It's the opposite sign. And then the integral between -5 and -3, that's the area between -5 and a -3. Now you're talking the area, you're talking between the curve and the x-axis. You're talking that triangle right there. And between the curve and the x-axis, you're talking that triangle right there. See how they're the same, triangle, same area, just one's above, one's below, so they're going to cancel each other out. We're going to get 0 for that. Let's do the -4 one next. When you do the integral, you're going to plug in the -4 for that x. That's, notice it's not least to greatest. So I switched them again. I switched the numbers and I switched that sign. I made that a negative. Now you're talking the area between -4 and -3. So now for this area, you're just talking this triangle right here, which is 1/2 times 1 times 2. And then the negative was there because I switched those 2 numbers attached to the integral. That is a positive area, so usually that integral is positive, but the negative carries over because I switched those numbers there, and so you get a -1 for that answer right there. All right, when you plug in the 4, right? You're doing the integral between -3 and 4, all right? So you're starting here and you're going all the way that way. Okay, now if you think about it, when you integrate, if you just look at that area from between -3 and 4, you're talking this whole trapezoid here. You're talking these regions here, and then these two triangles are going to cancel each other out. You see how there's a bunch? The majority of that is above the x-axis. So if that is majority above the x-axis, that means that area, that integral, will be a positive number. And so I'm expecting a positive number right here. And if I'm trying to find the absolute min, I already have a -1 right there, which is going to be smaller than any positive number that we could come up with. Okay, so you don't have to do all this work that I'm about to show you. Now, with that being said, I am going to show you the work just because I think it's good to get that understanding down in case you ever have to do it. But when I did the area between -3 and 4, I did the trapezoid, and that's we already found in part A was the 9/2. And then what I did here, I did the rectangle, which is 2 by 1. And I subtracted out the area of that semicircle, which is pi times the radius squared divided by 2. And that gave me these little, because it's between the curve and the x-axis, right there. And then you got a little triangle here and a little triangle here, that those are going to cancel out. I did a +1/2, -1/2, those canceled out. And if you did ever have to estimate this stuff without the calculator, just think pi is like, hey, it's kind of close to 3, right? So if I did 13 minus something close to 3, that would be something close to 10, and something close to 10 divided by 2 is something really close to 5 right there. But they got to give us stuff where you could tell what that minimum value is going to be without the use of that calculator. And again, if they say where's the max or min occur at, they want the x value. If those, as long as those just straight up say find the x value, but if it says find the min or find the value of the min, then they want that y value. That y value, the lowest y value, is at -1. Saucy.